I want to talk to you guys about programming languages tonight, and specifically the design and implementation of programming languages. And what I want to get from these next 10 minutes is hopefully to encourage you guys to look into what it actually takes to make a programming language, why the languages we have look and work the way that they are. Because I feel like that's a conversation that isn't had enough in the computer science community. We kind of just take C++ and Java as forces of nature. You know, they're just made by people in rooms. They're not magical. So I want to talk about myself a little bit. My name is Ramsey Nasser. That's my website. That's my Twitter. My background sort of defines my perspective on languages. So I studied computer science in AUB. So I am an actual computer scientist, but then I studied design in Parsons, and I did a year-long residency at the I-Beam Art and Technology Center in New York as well. So my perspective is very much a mathematical, theoretical, computer scientific one, which I got from AUB, but also a very human-oriented design one that I got from Parsons and I-Beam. And that's how I perceive languages. I see them as, you know, user interfaces to computers. So the sort of world that, like the ideal future that I see was outlined by Alan Kay in his personal computer for Children of All Ages paper, which, by the way, in 1968 predicted the iPad and the Kindle, but that's a whole other talk. He saw a world where people had a very healthy, very balanced relationship with technology, where the way you interacted with your hardware was that you programmed it, right? You weren't just consuming media on your iPad the way we are now. You were producing media as well, and you were writing code as well. And Alan Kay designed Smalltalk and Scratch and Squeak and a lot of the ideas that went to object-oriented programming trying to achieve this. That's obviously not the world that we live in today. But I'm very excited about empowering people to write code. And the reason writing code today is difficult, this is, 1972, by the way. So we live in a world that's a kind of a half-literate world, where people who have access to technology are generally able to read it, they can consume it, but they can't meaningfully write code, right? That's reserved to people who have invested the time and the energy to learn the bizarre tools like C and C++ and C#. And part of the problem is education. The way that code is taught is problematic. I know that there is an introductory CMPS course at AUB that guarantees that no one will ever look at programming ever again after they teach them Visual Basic. But a big problem is the tools. Like, we're stuck with languages that make assumptions that made sense in the 60s that don't make a whole lot of sense anymore. And these things aren't set in stone. They're just decisions that were made that can be rethought. And that's the conversation that I'm most interested in. Languages. So I want to talk about some explorations that I've done in this space and hopefully encourage you guys to do the same. So my thesis at Parsons was trying to look at programming languages as user interfaces. So like, how would you design a better remote control? Or how would you design a more intuitive car dashboard? That's how I was trying to think about programming languages. How would you make a language that just was more consistent and made more sense to the person using it? And so I made a language called Zejal. I named it Zejal because I'm proud to be Lebanese, but also when you Google Zejal, nothing comes up. So now it's just my language. So Zejal was sort of a reaction to processing. I don't know how many of you guys are familiar with that, but processing is a graphics-oriented framework that's based on Java that they use to teach a lot of artists how to code. And it's based on Java, which means you have to teach people static typing and all the weird, wonky Java syntax. I've had so many students ask me why string was capitalized but float wasn't. And it's like, well, primitive types and like classes and all these things that people who are beginning don't really need to worry about. So I built it in Ruby. I built it to be live coded and very, very interactive. And it had its moments. There's a video that I'm actually not going to have time to show. It was shown in galleries, and it had moments of people like really being excited because it's very easy to just modify values and just play around with to get interesting new results. But it's also, you can write real things in it. And because it's Ruby, you have Ruby gems and all those great things. But beyond just the user interface of code, at IBeam, I started to think about the sort of cultural assumptions that languages make. And the realization, especially having studied computer science here, that all modern programming is done in American English. And there's this drive around the world to teach everybody in the world code, and I'm very much a part of it. It's like, yeah, let's empower people with programming. But what comes with that is like, oh, we need to teach everybody in the world English, and that's imperialistic and very problematic. So to sort of explore that, I made a programming language called Elib, which I think, and correct me anybody if I'm wrong, is the first recursive Arabic acronym, because it stands for Elib Lughat Barmajeh, Qaf Lam Ba. So I was very proud of that, but I think there are 9 people in the world who would get that joke. And it's a Lisp done in Arabic. So you could see this is the code for the Fibonacci sequence. So Haddad Fibonacci, you're defining a function called Fibonacci, and you're storing it lambda noon, so an anonymous function that takes a parameter noon. And the code is asghar noon tnain. So this is conditional. It's Lisp syntax, so it's all parenthetical. Is asghar noon tnain, noon, so it returns noon if it's smaller than 2. Otherwise, it returns jama' Fibonacci tarah noon wahad, Fibonacci tarah noon tnain. So it returns the Fibonacci of noon minus 1, noon minus 2. And when you print out noon, the Fibonacci of 10, you get 55, which is the thing. And I want to show you guys, because everybody's doing cool demos, I want to show you my demo. So the longest one, I implemented Conway's Game of Life in it. Click. Oh, there we go. So this is Conway's Game of Life. It took me a day and a half to write. It's a nightmare. So when you run it, you get the implementation of the glider gun. That's as fast as I could make it run. This thing is so slow. So it's Turing complete. It's a real language by any definition of what a real language is. So it got some attention when I made it at IBeam, and a lot of people from here and from the Arab world were so excited, like, oh, we can write code in Arabic. And it's like, no, it's actually the exact opposite of that, because everything breaks when you don't use English characters. So this is my terminal font, just crumbling, trying to render Arabic. This is the first kind of renderings in Safari. I spent a lot of time looking at percent signs and symbols. GitHub renamed my repository to minus minus minus. Like, don't worry about it. No, we have a better name for your project. This is the terminal trying to display the contents of the folder. This is a diff in Git. I mean, so the point being that there's this illusion that we live in this Unicode world and everything has been internationalized, and that's absolutely not the case, right? These tools expect ASCII. Anything above code point 127 is going to be problematic, and that's the reality of it. So we're bound to English, capital letters, lowercase letters, punctuation, and a few other symbols, and that's it. Really, when you go below content and you start talking about infrastructure. And most programmers that I showed this to had never thought about that. People who even did not speak English as a first language. I never really thought about that until this project. And that's really alarming. And we have this incredible tool that is empowering that has the potential to empower so many people to make amazing things, that has the potential to build this incredible egalitarian relationship with technology, and it's bound to a single written culture. So I don't know what the way forward is. Individual languages in natural languages, so programming in Arabic and programming in Chinese and programming in Sanskrit, that's not the answer. This isn't a serious language. It's called Chinese Python, and it's exactly what you think. It's Python and Chinese, but this is what happens. So they have this Python script, and you still have to call range, R-A-N-G-E, because that's built into Python. You can't escape it. So if you wanted to make an all-Chinese or an all-Arabic programming experience, you'd have to redesign the last 50 years of software engineering. OpenGL is all in English. The HTML DOM is all in English. HTTP is all in English. I mean, you can't just translate, one thing and have everything work. So also, if you were able to get Chinese Python or Arabic Lisp to work, you're still alienating people who don't speak these languages. So I don't really know what the answer is, but translating English programming languages into natural languages is not the solution. These things are not usable in any meaningful way. So some of my other experimentations, I recently played around with emoji to make like a language agnostic programming language. This is Emotional. It's a stack-based language that only uses emoji symbols. It's also, I actually haven't proved it Turing complete yet, but it's close. It's not running here. It actually only runs on iPads because they have the full emoji symbol set. But this is an implementation of Brownie in Motion. So it's based on language like Forth, if you guys are familiar with Forth, or PostScript. So it's pushing things to the stack. And so like palette line, it's drawing a line from like X, Y to previous X, previous Y. This is just not ever going to be useful, but just also an exploration into like, is the solution that we just eliminate natural letters altogether, like natural language altogether? I don't know. So I have a friend who just tells me that I make ridiculous things and just put them online, but this is an example of a real language that I'm working on. It's based on a novel method of message passing that implements sort of simultaneously multi-methods and object-oriented programming. It's based on queries, so any object that receives a badge effect message, depending on whether they match one of these queries, a different function will run on that object. This is something that I'd love to talk to you guys about in the break, but I'm already over time. So I think languages are absolutely crucial. I think having a conversation around the tools that we use and the tools that we surround ourselves with isn't happening enough, and I think that's something that really needs to happen. So make programming languages, guys. Thank you.